Okay, so the standard form for the quadratic equation looks like this. Ax squared plus bx plus c equals 0. And that should be familiar because remember, if you're going to solve a quadratic equation by factoring, what number needs to be on the other side? 0. So you can use a zero factor property. So the same thing when using quadratic formula. So if you're going to use a quadratic formula, it's got to be in standard form. Okay? Now the quadratic formula looks like this. Now I'll give you the formula, you just got to know how to use it, but it looks like this. So your solutions will be the opposite of b, looks like this, the opposite of b, that's how you're going to read it. You're going to say the opposite of b plus or minus the square root of b squared minus 4ac. So b squared minus 4ac is your radicand. So all that's under the square root. And the whole thing, now notice when I do the division symbol here, I'm going from negative b all the way to the end of that square root symbol. So I'm going to go from negative b all the way to the square root symbol. And all that's being divided by 2a. Now, there's a derivation for this. And you didn't do this, but if you were to complete the square, something called completing the square, you're going to talk about completing the square next semester. But if you were to complete the square on this, you would actually get this formula. So this formula is a derivation from this. You just don't know how to do it. But that's a formula. You just got to be able to use it. Keep in mind, though, you see that in the formula are the letters A, B, and C? Okay, so A is the coefficient. See, I'm circling it. A is the coefficient of x squared. Okay, B, and I see two variables with B. B is a coefficient of x. See this x? B is a coefficient of x. And C is your constant. C is your constant. Okay? All right. Now, remember, always follow the direction. So if the direction says solve by factoring, you factor. If the direction says solve by using the square root property, you use the square root property. If the direction says solve using a quadratic formula, you use a quadratic formula. If there are no directions, then you can solve either way. But remember, are all quadratic expressions factorable? No, they're not all factorable. Remember, you had some that were prime? Okay, so they're not all factorable. So the question is, can I solve every quadratic equation by factoring? No. Okay, you cannot. But can I solve every quadratic equation using quadratic formula? Yes. Okay? All right, number one. Let's suppose I had this. We're going to start with the simple one, x squared plus 2x minus 35 equals 0. X squared plus 2x minus 35 equals 0. What kind of equation is this? Quadratic. Is it in standard form? Yes. And always make sure it's in descending order. So you're going from largest exponent to your constants. Your constants listed last. So I want to solve this, though, by using the quadratic formula. So what I would do first is indicate what A, B, and C are. So what's A in this case? No, A is not x. A is 1. A is a coefficient of x squared. What am I multiplying x squared by? That's 1 right here. What's the coefficient of, what's B? What's the coefficient of x? 2. And C, remember, is your constant. What's your constant here? Negative 35. You see, if you put 35, then your solution is going to be incorrect. So you got to make sure that these are correct right here. Otherwise, all that work will be for nothing because you'll have the wrong solutions. All right. Now the next thing you do is you plug and chug. Plug it back to your formula and chug this thing out. Now, as you go through the process, though, remember when we solved these quadratic equations earlier, these solutions were rational or irrational? Irrational. These were real or imaginary? imaginary solutions. Okay? So as we go through this, we're going to talk about the word discriminant. And the discriminant, by the way, is just your radicand that you see here. So your discriminant is b squared minus 4ac. And so as we go through this, we'll refer to the discriminant and see if it kind of makes sense that the solutions we got are what they are. So basically, the discriminant will tell you how many solutions you're going to have and what type. Okay, so how many solutions you're going to have and what type. All right, so let's go ahead and use a formula. So my solutions are going to be x equal, all right, first of all, what's b in this case? 2. So this says the opposite of 2. So what's the opposite of 2? Negative 2. Plus or minus the square root of. All right, now remember, the radicand is the discriminant. So what I would do at that point is I would put everything in parentheses. So in other words, I would say b in parentheses. What's b here? 2, just like I'm doing. But what must I do to 2? Squared. Minus 4 times a in parentheses. What's a? 1. And then times c, and what's c? Negative 35 in parentheses, just like this. And then remember, always make sure your division symbol goes from negative 2 all the way to the end of the square root symbol. And all that's being divided by 2 times a, and what's a in this case? 1. All right, so that's the first thing you had to do, or one of the first things you had to do. Now we're going to simplify the radicand. We're going to simplify the discriminant. So I'm looking at my discriminant right now. So I got negative 2 plus or minus the square root of. All right, let's talk about the discriminant. What's 2 squared? 4. All right, so 4. Now what's a negative 4 times 1 times a negative 35? Huh? What's a negative 4 times a positive 1 times a negative 35? Take your alone time. Negative 140 or positive 140?
Positive 140.
Positive 140, because a negative times a positive times a negative is a positive. So again, so you see how some of you said negative 140? You got to be careful. All that's being divided by 2. Now look at my discriminant. What is the value of my discriminant? What is your discriminant here? Huh? 144. That's your discriminant. Remember, your discriminant is your radicand. So I get negative 2 plus or minus the square root of 144 divided by 2. Now let's talk about that. 144, is that a perfect square or not a perfect square? It's a perfect square. So if your discriminant is a perfect square, if your discriminant is a perfect square, I want you to notice what's going to happen. What's the square root of 144? 12. So I get negative 2 plus or minus 12 divided by 2, right? So if the discriminant is a perfect square, you're going to end up with what kind of solutions? Rational. You get rational solutions. Because my discriminant is a perfect square. So if the discriminant is a perfect square, you're going to get rational solutions. Now, since this is rational, you have to rewrite it a different way than you did here. See how when we did this, how the irrational ones look like this? See how it look? The rational solution is going to look a little bit nicer. So you're going to say negative 2 plus 12 divided by 2. And what's the other solution? Negative 2 minus 12 divided by 2. But you got to go further. Don't leave it like that. Because you know what negative 2 plus 12 is. What's negative 2 plus 12? 6. And what's 6 divided by 2? I'm sorry, 10. Excuse me. What's 10 divided by 2? 5. So that's one of your solutions. So x equals 5 is a solution. So notice that 5 is a rational number. Your other one, what's negative 2 and a negative 12? And what's negative 14 divided by 2? Negative 7. So there's your other solution. So you have how many solutions? 2. And they are what kind of solutions? Rational. And you knew they had to be rational because your discriminant was a perfect square. Now I want to mention something though. You see how the discriminant is a perfect square? If the discriminant is a perfect square or 0, if the discriminant is a perfect square or 0, you can solve this by factoring. You can solve by factoring. So the discriminant was a perfect square at 0. You could have solved this by factoring. But that wasn't the directions, right? The directions say solve by factoring or solve by using quadratic formula. Quadratic formula, so you have to follow directions. But let me just remind you about this. So I'm going to go back right here. I'm going to rewrite the equation. X squared plus 2x minus 35 equals 0. Now, according to this, the discriminant is 144, so I could have done this by factoring, couldn't I? Yeah. So if I factor this, I get XX, 7, 5, and the 7 has to be plus and the 5 has to be negative. And then I use a 0 factor property. X plus 7 equals 0. X minus 5 equals 0. So what's x over here? And what's x over here? So it was a lot easier to have done this by factoring. But that's not what the directions said. The directions said they wanted you to use the quadratic formula. But the point is you have to use the quadratic formula at some point because is every quadratic equation factorable? No, it's not. All right, let's look at number 2. Okay, number 2, you have this. You have 3x squared equal 12 minus 16x. 3x squared equal 12 minus 16x. Okay, so what should you do first? Rewrite it in standard form? Okay, so and just make sure it's in descending order. So tell me what you would write. You'd say 3x squared and what else? Plus 16x, good. And then what? Minus 12 equals 0. All right. So again, you could have, if you're not careful, you could have easily messed up with the signs here. Now before using quadratic formula, let's go ahead and denote what A, B, and C are. What's A? What's B? And what's C? Negative 12. All right. So now we're going to use the formula. So x equal the opposite of B. What's the opposite of B? Negative 16 plus or minus the square root of B squared. And what's B in this case? 16. What must I do with that 16? Squared minus 4 times A. What's A? And what's C? Negative 12. Notice I'm putting, when I'm writing my discriminant, I'm putting all these in parentheses. All of that's being divided by 2 times A, and A is 3. Okay, so that's what I have. So once you get to that point, everything else should be fine. So the places in which you could have easily made a mistake was when you transposed or when you brought the terms to the other side. You could have easily messed up with the signs there for some of you. The second way you could have messed up was when you wrote A, B, and C, you probably forgot about the signs as well. But plugging in should not be the issue. And then using a calculator, that point should not be the issue. So you have negative 16 plus or minus the square root of. Use your calculator and tell me what 16 times itself is. 256, right? What's a negative 4 times 3 times a negative 12? What's a negative 4 times 3 times a negative 12? Positive 144. All divided by 6. Okay, so I get negative 16 plus or minus the square root of. Now tell me what the discriminant is. 400. Is the discriminant a perfect square? Yes. In fact, use your calculator. You can tell if it's a perfect square because when you take the square root of it, of 400, you get a whole number. If you got a decimal, then it would not be a perfect square. The square root of 400 is exactly what? 20. So 20 times 20 is 400. So 400 is a perfect square. Don't forget to say divide by 6, though. So notice the steps. You say divide by 6. See how I'm writing? Just write it like this, like I'm doing. So now the square root of 400 I can write as 20. So how many solutions will I have? 2, and what kind? Rational. So negative 16 plus or minus 20 divided by 6. All right, now split it apart. So these are rational solutions. So I get negative 16 plus 20 divided by 6. And what's the other solution? Negative 16 minus 20 divided by 6. What's negative 16 plus 20? 4, 6. And if you want to, and if you left it as 4, 6, you got to that point, you left it as 4, 6, I'd give you full credit. But you know that 4, 6 reduced is what? To 2/3. That's one of your solutions. Okay, over here, what's negative 16 and a negative 20? Negative 36. And what's negative 36 divided by 6? Now, I expect you to rewrite that. Don't leave it like that. What's negative 36 divided by 6? Negative 6. So those are your two solutions. Okay? All right, let's go to number 3. Okay, number 3. Okay, number 3, let's suppose we had this. X squared plus 3x minus 2 equals 0. So x squared minus 3x minus 2 equal 0. Okay, is this quadratic equation in standard form? Yes. So what's A? 1. What's B? And what's C? All right. Now let's plug this into the formula. So x equal the opposite of B. What's the opposite of B? Negative 3. Plus or minus the square root of B, which is 3 squared. Minus 4 times A. What's A? 1 times C, and what's C? All divided by 2 times A, and A is 1. Okay, now let's talk about the discriminant. I got negative 3 plus or minus the square root of, what's 3 squared? 9. What's a negative 4 times 1 times a negative 2? All right, positive 8, so I get 9 plus 8, all divided by 2. What's 9 plus 8?
17.
So what's the value of the discriminant? What's the value of the discriminant? No, what's the value of it, though? Tell me what it is. No, not square root of 17. The discriminant is just the part that's under the square root. It's b squared minus 4ac. So what's the discriminant? 17. 17 is the discriminant. Is 17 a perfect square? No. In fact, if you hopefully you knew that, but if you didn't and you use your calculator, you took the square root of 17, you don't get a whole number. You get this decimal that's an irrational number. Okay? So, now the other thing is, can I simplify the square root of 17? Is there a perfect square other than one that goes into 17? No. So leave your answer like that. You're done. Okay? Notice the difference between the one we just did, let's say, in number 1. See, 144 is a perfect square. So you end up with what kind of solutions? Rational. 17 is not a perfect square, so you end up with what kind of solutions? Irrational. Okay? Now, so on the worksheet, though, and next semester, when you actually graph these quadratic functions, you're going to have to estimate, and these happen to be your x-intercepts. You're going to see that next semester. But you're going to have to approximate this, your x-intercept. So let's talk about approximating it. See, these are your exact solutions. So I'm going to call this exact. So in the worksheet that you're going to get, there's one worksheet that says exact and then rounded, approximated. So that's your exact. Okay, now let's talk about our approximations. So there are how many solutions here, though?
2.
2. All right, so we're going to approximate. So we're going to approximate our solutions. It's going to say round to the nearest tenth. So here's how you do this. Now listen carefully. Follow along with your calculator. So you're going to say that you're going to do the numerator first. So what do I type in? -3. What else? Plus. And then what else? Square root. So I'm pressing the square root button. What else? 17. Now that's a numerator. What else should I then do at that point? Now, say equal first. If you divide, you're gonna only dividing by you're only dividing 2 into the square root of 17 instead of the whole thing. So that's why you need to do inner first so you don't mess up. Now divide by what? 2. Press equal, and one of my solutions is approximately equal to 0.6, nearest tenth. Okay, so what I got? 0.6. Now how do you find your other approximate solution? -3 minus square root of 17. What do I press? Equal. Then divide by 2. So what's the other approximately equal to? -3.6. Okay. All right. So when you're going to see what that worksheet is going to look like. It'll say exact, so you just write this, and then it'll say approximation, so you have to write 2 separate numbers to the nearest tenth. It'll say nearest tenth. All right. Let's do number 6. Number 6. So number 6. I'm sorry. Number 4. That look like. Sometimes I can't read my own handwriting. So that's 3. This is 4. All right, number 4. You have 2x squared minus 3x minus 3 equals 0. 2x squared minus 3x minus 3 equals 0. All right. So for the most part, you should get most of these points, if not all of them. Because first of all, is this in the correct form I need it in?
Good.
Yes. So it's in standard form. So now you can tell me what A is. What's A?
2.
2. What's B? -3. And what's C? -3 as well. And now all you have to do now is just take these values and plug it into your formula. So remember, the formula is -b plus or minus the square root and the discriminant, which is b squared minus 4ac, all divided by 2a. So I'll give you that. You don't have to memorize it. I'll give it to you. You just need to know how to use it. So x equal, all right, so this says the opposite of b. What's b in this case? Negative 3. What's the opposite of that? Positive 3. Plus or minus the square root of, okay, put parentheses, negative 3 squared, right? Minus 4 times a, what's a? 2 in parentheses times c in parentheses, which is negative 3. All of that, make sure you extend that division symbol all the way. 2 times a, so that's 2 times 2. All right, we're going to simplify the discriminant. I get 3 plus or minus the square root. All right, now what'd you get when you said negative 3 squared? 9. Anyone got negative 9? Should it ever be negative? No. Remember b squared. Let's talk about b squared. No matter what b is, if b is negative, what's a negative times a negative? Positive. If b is positive, what's a positive times a positive? Positive. If b is 0, what's 0 times 0? 0. So is b squared ever going to be negative? No. So never. Be careful, because on your calculator, you probably, if you did it incorrectly, you probably said negative 3 squared, just like this. Now that gives you negative 9, but you know you made an error, because it should be negative 3 in parentheses that's being squared. So that's 9, and then what's a negative 4 times 2 times a negative 3? Positive what? 24? All divided by 4. Okay? So I get 3 plus or minus the square root of 33 over 4. Now, what is the discriminant? 33. Don't say the square root of 33. It's just what? 33. Is 33 a perfect square? No. So I'm going to end up with what kind of solutions? Irrational. All right. Now, can I simplify the square root of 33, though? What perfect square goes into 33 besides 1? Can I simplify the square root of 33? I'm asking it again.
Oh, no.
No. So there's your answer. Now, go ahead and approximate. If they say approximate, let's approximate. So the nearest tenth, what do I type in? 3 plus square root of 33, and we press equal, and then divide by 4. And what's one of my solutions approximated? 2.2. Okay, that's one of them. Your other one, you're going to say 3 minus the square root of 33, press equal, and then divide by 4. What's the other solution approximated? Negative 0.7. Okay. All right, number 5. Number 5, suppose we had this. We had 3x squared plus 6x equal negative 1. 3x squared plus 6x equal negative 1. All right. So how do we write it? 3x squared plus 6x plus 1 equals 0. All right, so we put in standard form. What's A? What's B? And what's C? 1. So I get x equal the opposite of B. What's the opposite of 6? Negative 6 plus or minus the square root of 6 squared, B squared, minus 4 times A. A is 3 times C, which is 1, all divided by 2 times 3. So let's simplify the discriminant. So I get negative 6 plus or minus the square root of 6 squared is 36. What's a negative 4 times 3 times 1? Negative 12. All divided by 6. So I get negative 6 plus or minus the square root of, what's the discriminant? 24. Is 24 a perfect square? No. So there's going to be irrational solutions. All divided by 6. All right, now listen carefully. So remember, you have enough information now to where you can simplify that square root. Can I simplify the square root of 24? Yes. All right, so let's go ahead and simplify this. Square root of 24, remember, what perfect square besides 1 goes into 24? That's 4 times 6. And what's the square root of 4? That's 2. Square root of 6. So I get negative 6 plus or minus 2 square root of 6 divided by 6. Okay? Now, if you got to that point, you should get all your points. I'll give you all your points. You get all to this point right here, I'll give you all your points. Now, this would be your exact solution. Okay? Now, remember on the worksheet, though, on the worksheet, they're going to ask you to approximate this. So let's talk about approximating. Let's talk about approximating. So on your calculator, you're going to say negative 6 plus. Now, you see, some of you, listen carefully to this now. Listen. So you see how I simplified this? Some of you could have messed up around here, right? So what I would do is I would just go back and use the square root of 24 in the approximation. So I'd say plus the square root of 24, press equal, and then divide by what? By 6, and press equal again. So that's about negative 0.2. Now, what you might want to also do then is this. Do the other one and see if you did this correctly, the simplification. So you got to be careful, though. Now, here's how you can do this. Just remind you what to do. So you get negative 6 plus 2 square root of 6. See how I did it? Look, negative 6 plus 2 square root of 6. Press equal. Then divide by 6. You should get the same thing. See it? Okay. Now I'm going to go ahead and use this one instead. So the next one then would be negative 6 minus the square root of 24. Press equal. And then divide by 6. Press equal. And the other one's a negative 1.8. Okay. Now, a couple of things I need to mention. So, again, if you got to that point, I'll give you full credit. But in my math lab, they're going to ask you probably to simplify. So let me just kind of remind you about something. You can go further. All right, you can go further with this. So let me just talk about this for a moment. I'm going to rewrite this over. So there's several ways you can think of this. Okay, now listen to this. So you see there are how many terms in this numerator? 2. How many terms in the denominator? 1. Okay, so whenever there's just one term in the denominator, then what you can do, every term that's in the numerator, you can rewrite it as separate fractions. So in other words, this can become negative 6 divided by 6 plus or minus 2 square root of 6 divided by 6. You agree?
Yeah.
And then I can reduce negative 6 divided by 6, which is what? Negative 1 plus or minus, and I can reduce 2/6 here, which is 1 divided by 3. So that's the square root of 6 divided by 3. So that's one way. Okay? But you can stop here, though. But I just want to remind you about this approach as well. The other approach is this. I'm going to circle these numbers right here. And those three numbers, what do they have in common? What's the common factor? 2. All right. So I'm going to rewrite it. So I'm going to show you this. All right. Listen carefully. 2 and a 6 is
1.
no.
2 and a 6
Is
3.
3. 2 and a 2 is 1. 2 and a negative 6 is negative 3. So the other way of writing the answer would be to say negative 3 plus or minus square root of 6 all over 3. All right? But for our purposes, leave it like this. But these are different ways of going further and rewriting it in different ways. Just different ways of writing the solution. That's all it is. Just a different way. But it's important you also know that I can write this as 2 separate fractions. Okay?
So which one?
I would leave it like this.
No, but which one was my math lab too?
Your Math Lab is probably going to say simplify, so this is probably the one it's going to want. But it does it in such a way to where if you let me rephrase it. You have to use. It's probably going to say write separate solutions with a comma. So you'd say negative 3 plus the square root of 6 over 3, comma, negative 3 minus square root of 6 over 3. Okay. Now you could have also done this one because it does it in such a way to where all the different possible answers are there. So negative 1 plus the square root of 6 over 3, just like this. And what's the other one? Minus square root of 6 over 3. All right?
So either or.
Yeah, it should be either or. Now remember, you have unlimited
Yeah.
chances. All right, so it should be one of these. It may give you credit if you wrote it as negative 6 plus 2 square root of 6 over 6, and then negative 6 minus 2 square root of 6 over 6. Just see. Okay? All right, now, so that's the end of that part.